Hello, and thank you for the invitation to speak at the Nitrogen Conference this year. My name's Carl Rosen, and I'm an extension soil scientist at the University of Minnesota. My talk today will summarize a 3-year study we conducted to determine nitrogen credits for field corn following sweet corn, and also to determine the effect of cover crops on nitrogen carryover. This time, I'd also like to acknowledge my co-authors for their help in field plot maintenance, data collection, and analysis, as well as our funding source, FREC. Topics I'll be covering today will include a little bit of background on sweet corn production in Minnesota and the motivation for conducting this nitrogen credit study. Then we'll get into the nitrogen credit study itself, how the previous crops were established, and then finally, how field corn responds to nitrogen following those previous crops. So sweet corn in production in Minnesota, it's grown on about 120,000 acres. Most of the sweet corn is used for processing. It's often in rotation with soybeans, sugar beets, or field corn. And unlike field corn, sweet corn is harvested as an immature crop. The harvest usually starts early August to mid to late September. It's because it's immature, the, the crop is relatively green, but it also gives us time and opportunity to establish a cover crop. And that's something that we wanted to take advantage of in this particular study. Before I get into our nitrogen credit study, I just want to give you a little bit of background for why we decided to conduct this study in the first place. We did a comprehensive nitrogen management study on sweet corn back in 2014, 2016. We looked at hybrids, we looked at plant populations to planting dates, we looked at various nitrogen treatments. And I'm not going to get into a lot of detail on this study, but the overall summary is that the optimal nitrogen rate for sweet corn following soybeans in a dryland, high organic matter soil was somewhere between 120 and 180 pounds of nitrogen per acre. But one of the more remarkable findings in that study was about 60% of the nitrogen taken up by sweet corn was still in the stover at harvest. There could be as much as 60 to 70 pounds in the residue, and that was going back into the soil. And the carbon to nitrogen ratio of that residue was between 30 and 40. This is relatively low compared to field corn. Because you have a low carbon to nitrogen ratio, that means that there is potential for mineralization, nitrogen release in the fall, and also nitrogen release in the spring. Now, some of that nitrogen might be available for the next crop, but some of that nitrogen might also be susceptible for losses. And that's one of the reasons why we looked at cover crops in this particular study. So the overall objectives of the nitrogen credit study was to determine the effect of sweet corn as a previous crop relative to field corn and soybean on field corn nitrogen response. We already know how field corn responds to nitrogen following soybeans, but we don't know how it responds following sweet corn, and we wanted soybean as kind of a control in this particular study as well. Another objective was to determine the effect of a rye cover crop following sweet corn on field corn nitrogen response and nitrogen carryover. Kind of the overarching question that we wanted to ask was, can nitrogen rates be lowered for field corn if sweet corn is the previous crop? And currently, we don't give any credit for sweet corn, so we felt this was an important study to investigate. So the first step was to establish the previous crops and the rye cover crop. So previous crops were established in 2017, 18, and 19. We used a different field each year for the establishment of those previous crops. And then the field corn nitrogen response then was conducted a year after those previous crops were established. So the N rate studies were conducted in 2018, 19, and 20, and we evaluated 6 N rates, and I'll get into that in a little more few slides. All studies were conducted at the Southern Research and Outreach Center in Waseca under rain-fed conditions. This gives you a little idea of how the study was set up. So in 2016, 17, 18, we selected a block of field corn at the Research and Outreach Center. This was a large block of field corn. And then within that large block, which we call year zero, which was 2017, 18, and 19, we established the previous crops. We used 4 replications, so you can see that there's 4 previous crops and 4 replications, so there's 16 plots. So the previous crops were corn, so we had a corn-corn rotation, a soybean corn rotation, a sweet corn rotation, a sweet corn followed by rye corn rotation. And this gives you an idea of the nitrogen rates that we used for the previous crop establishment. This also, next slide gives you an idea of the yields that we obtained. So the field corn, about 170 bushels per acre on average over the 3 years, 53 bushels for soybeans, and about 5.5 tons for the sweet corn. We measured the dry residue in those fields that remained after harvest, the carbon to nitrogen ratio of the residue, and we also measured how much nitrogen was actually left in that residue as well. So you can see anywhere from about 36 to 54 pounds, depending on the previous crop. And the C to N ratio was 35 for sweet corn, which is relatively low, meaning that there could be some mineralization, to fairly high with field corn, where you would actually get immobilization with that high C to N ratio. Then for one of the previous crop replications, the previous crops, we needed to establish a cover crop following the sweet corn. So the sweet corn was harvested in mid-August. We planted the rye within about 2 to 3 weeks afterward. We got in there at the end of August or early September. The rye then was killed in the following spring in early to mid-May, and then the rye was then disked in 3 to 8 days later, depending on weather in many cases. This gives you an idea of what the sweet corn crop looked like at harvest. A lot of green matter there, so relatively low carbon to nitrogen ratio. We went in after harvesting that sweet corn with a no-till grain drill. Again, that was about 2 weeks later after harvest. And after we planted, you can see this is in 2017, first week in September. If you look closely, you can see some of that rye starting to emerge between the sweet corn rows. About a month later, the rye crop was established. Following spring is what this slide shows. You can see the rye is fairly tapped down due to a recent snowstorm this particular year. A couple weeks later, it's starting to recover. And then in early May, it's fully recovered. We would kill the crop, wait a few days, and then disk it in. This is what it looks like after disking. And then we would plant the field corn. This is a similar set of slides, but just shows a different year. In October of 2019, you can see the field crop, the field corn in the background, but the rye crop establishing. Then the following spring, you can see that rye crop looking fairly green. In the background, you can see where that field corn was harvested the previous year, showing quite a bit of residue there. So the rye cover crop had the biomass was collected. So you can see it ranged anywhere from 0.8 tons dry matter to about 1.7 tons in 2020. So a lot of biomass in 2020. We let it go a little too long, I think, that year, and you'll see some consequences of that. The amount of nitrogen in the rye cover crop ranged from 57 to 84 pounds. So you can see it is tying up some of that nitrogen or taking that nitrogen up out of the soil. The carbon to nitrogen ratio also differed between the years. So we had a much higher carbon to nitrogen ratio in 2020 than the previous 2 years. And again, I'll show some consequences of that in the subsequent slides. In terms of fall nitrate, both in the fall after the cover crop was established and then the following spring before it was terminated. You can see that when there is rye there with the sweet corn, the lowest amount of nitrate was in that particular scenario. Both the fall of the year of that establishment of that rye crop and then in the spring just prior to termination, there was lower amounts of nitrate in the profile. And this is what you would expect because that rye crop is taking up the nitrogen and it is in the tissue of that rye crop relative to no crop at all with sweet corn, field corn, and soybean. There was much higher levels of spring carryover nitrogen. So this is a good thing for the rye. It's doing what it's supposed to do. So we established the previous crops, either field corn, soybean, sweet corn, or sweet corn and rye. And then we imposed 6 nitrogen treatments, anywhere from 0, no nitrogen, all the way up to 250 pounds of nitrogen per acre in 50-pound increments. We also applied phosphorus, potassium, and sulfur to ensure no other nutrients were limiting. And all of these fertilizers were applied pre-plant. Field corn was planted mid-May each year. And then we followed that growth. So just to kind of recap what we did, the year prior to previous crop establishment, we selected a large block of field corn. That field corn was harvested, and then we planted the previous crops, 4 previous crops in large blocks and replicated 4 times. And within each block, we then imposed year 1 different nitrogen treatments. And then we grew field corn during that year 1 and measured yield during those years with the different nitrogen rates imposed. So this slide shows the effects of previous crop on the economically optimum nitrogen rate. What you can see in all cases is that the Eonr was highest when field corn was the previous crop compared with soybean or sweet corn. The one exception was the third year, 2020, when the Eonr with sweet corn and rye as the previous crop resulted in a slightly higher Eonr than the corn-corn rotation. This is likely due to the higher carbon to nitrogen ratio of the rye crop in the third year, and it indicates that if rye is planted, there may not be an N credit if that termination is delayed. Another interesting result from this study is that the Eonr for the corn-corn rotation was much higher the first 2 years compared with the third year. And this is likely due to 2 very wet seasons in 2018 and 2019. The third year, 2020, was much, much drier. So we think that had an effect on that Eonr that third year. This slide shows the overall average effects of previous crop on the Eonr and the yield at Eonr. We can clearly see that there's an N credit with sweet corn as the previous crop, which is slightly less than the credit for soybean. The yield in a corn-corn rotation at the Eonr is also less than the yield with the soybean or sweet corn as the previous crop. This indicates that there's a rotation effect in addition to a nitrogen credit effect. The rotation effect shows up a little more clearly in this slide, where the nitrogen rate applied is plotted against the relative yield. This is an average over the 3 years. And you can see that adding more N to the corn-corn crop, it did increase yield, but only up to a point. And it never reached the yield that you would reach with soybean or sweet corn as the previous crop. It was always lower. So this indicates there's a rotation effect going on in addition to a nitrogen credit. So overall, we can conclude that yes, there is a nitrogen credit when sweet corn is the previous crop, with or without rye. We think that this nitrogen credit is slightly less than soybean. Field corn yields were higher following sweet corn and soybean than following field corn. So corn-corn rotation had lower yields than a sweet corn-corn or a soybean corn rotation. And adding more nitrogen helped in the continuous corn rotation, but there was also what we would call a rotation effect that could not be overcome by adding more nitrogen. The rye cover crop did reduce soil nitrate in the fall or spring, but you need to be a little cautious. If you delay termination, if you have too much rye biomass, it's going to result in a no nitrogen credit. For future research, we think other cover crops need to be evaluated. Something like oats or tillage radish, both of these will winter kill, so you don't have to worry about termination the following spring. We think that this is something that needs to be investigated further. So with that, that's the end of my presentation. I'd like to thank you for your attention, and if there's any questions, I'd be happy to take them at this time.